Hello everyone, my name is Pratik Rakesh Singh, roll number 20ME10063. So, topic for our mechanism sessional assignment number 5 is to synthesize and create a simulator for windscreen wiper mechanism. This group project is collectively presented by myself, Pratik Rakesh Singh, roll number 20ME1063, Akshat Jaiswal, roll number 20ME10007, Yashwardhan Mahesh Vasu, roll number 20ME30071. So, we use linkage open web simulation software for simulation portion. It enables us to create and execute mechanical simulation using elements that have a highly realistic appearances. Various tools, including join, fasten, and log angle, may be used to design and structure of mechanism. And we utilized rotating input RPM from the properties menu to describe the parameters of the mechanism. Now, the link between angle theta 2 and output theta 4 is therefore being provided by the displacement analysis. So, we'll look into this part of displacement analysis of the kinematic mechanism. As you can see in the figure, the link lengths of the above kinematic diagram are AB equal to L1, BC equal to L2, CD equal to L3, and AD equal to L4, where AD is the ground and DE is equal to L0, is the extension and links the CD to the mechanism with the wiper. As a result, we can see we can choose A as our origin with AD as a x-axis and y-axis which is perpendicular to it. Now, with respect to A, we can find the coordinates of B and C. And we can see that coordinate of B is L2 cos theta 2 and L2 sin theta 2. And C is L1 plus L4 cos theta 4, comma L4 sin theta 4. As we already know B and C, we can find the distance between B and C using the Euclidean distance formula. So we get the distance between B and C equal to L1 plus L4 cos theta 4 minus L2 cos theta 2 whole square plus L4 sin theta 4 minus L2 sin theta 2 whole square. Now, as we have all these equations, what we can obtain the length L3 with respect to theta 4, as we already know all the other terms. So, using trigonometric equations and the half angle relations, we can find the value of theta 4 and all the coordinates of all the other points that are used in the mechanism. Finally, we get the theta 4, that is 2 tan inverse minus a plus minus root under a square plus b square minus c square by b plus c. And a is nothing but sine theta 2 and b is cos theta 2 minus L1 by L2. Same way, we can get value of tan theta 3.
Hello everyone, my name is Akshat Jaiswal, roll number 20ME10007. I will be explaining velocity and acceleration analysis along with the torque analysis. So the velocity analysis provides a relation between input velocity and output angular velocity. From Aron-Holt-Kennedy theorem, we know that if three bodies are in relative motion, they must have collinear IC. As L2, L1 and L4 are in relative motion, I13 must lie on I14 and I34. Similarly, L2, L3, L4 are in relative motion. Therefore, I13 must lie on I23 and I12. Thus, we can find that I13 is at the point X. Now, we had obtained the displacement equation where A, B, and C are function of lengths and angles. The displacement equation obtained is a result of equating the magnitude of vector L2 to L4 with the length L3. Upon time differentiating the displacement equation, we get the velocity equation where in terms of Jacobi, which is denoted as J. Here we can see that theta 4 dot is equal to L2 by L4 into L4 sin theta 2 minus theta 4 plus L1 sin theta 2 upon L2 sin theta 2 minus theta 4 plus L1 sin theta 4 times theta 2 dot, which is represented as Jacobi. So theta 4 dot is J times of theta 2 dot. Differentiating further, we get the acceleration analysis, which is theta 4 double dot is equal to del j del theta 2 plus del j del theta 4 times j theta 2 dot square plus j theta 2 double dot. Now we have the equations for del j del theta 2, del j del theta 4 and a, b and c. Therefore, we can get the acceleration as well as the velocity. Now we move on to the torque analysis. So in torque analysis, the torque required of motor, for that we assumed constant load moment due to constant friction force, and it gives us the output torque for the given input torque the virtual work done by the mechanism is zero. Therefore, we can equate the input work and output work to get the equation tau 1 is j times of tau 4, where j is the Jacobian obtained from the velocity analysis.
Okay, so hello everyone. My name is Yashwardhan Vasu and my roll number is 20ME30071. I am going to demonstrate here the synthesis, graphical synthesis of our windscreen wiper mechanism and also its simulation. So here you can see the graphical approach that I have drawn here. I have used a scale of 1 centimeter equivalent to 2 centimeter. Further, the original link lengths are given in the question, which are also given here. So here you can see that with taking O4 as the center and O4C1 as the radius, we get the arc of C1C2. So this arc will help us in calculating the area of the shaded region which is swept by the wiper. So from graphical analysis, we get this angle beta as 63.617 degree. Now this I have considering C1 C2 as the arc of the area swept by the wiper blade and O4 C1 as the radius which is equal to 300 millimeter as the radius. So we calculate the arc length as beta by 360 into 2 pi r, which is equal to 33.31 centimeter. Therefore, the area of the shaded region is C1 C2 times the length of the wiper blade, which is E1 F1 here. Therefore, area comes out to be 666.2 centimeters square. Now, moving to the simulation. So, here you can see the simulation which I have made using this linkage software. It is a and free to use and simple software. So, here you can see the simulation model along with the shaded area that will be swept by this wiper. This software provides ready-made linkages, motors, actuators, etc., which can be connected to each other by this join option shown here. So with a simple left click here, we get the required links, these links, motors, etc., and the curved lines, polygon option, and the curved lines to make the swept area. So here I have used this binary link and ternary links to make the links of my mechanism as shown here. These links. Further, I have used these line option and this curve line options to make the area swept by the wiper and the wiper itself. At last, the wiper was joined by the revolute point M by this fasten option here. Now, to make this model look like real, we can change its properties to solid as shown. So here is our final model. Now let's run the simulation. So here you can see how the wiper sweeps the shaded area. Further, to increase the area held by the wiper, we need to just increase this crank length here. If we increase this crank length, we can extend the area swept by the wiper. So thank you all for listening us patiently.